All right, 7-5. Let's use the old trusty triangle that I always use. I always use this one right here. Oh, why did trusty triangle? Let me try this again. There we go. All right, there it is. Remember this triangle? I use it all the time.
You should make it pink.
Pink? A pink triangle?
Yes. Yeah, pink triangle.
What am I, a girl
Try
or something? A pink?
Yeah.
How's that?
Yeah.
You like that better?
Make it thicker.
Thicker? I already made it 2-point.
Thicker.
Thickerer? Made it.
No, 4.
That's 3-point. How's that look? That's
A little bit
3-point.
thicker.
That's good. All right. So what we're gonna do is this. We got actually 4 different things we're gonna do. 3 of them are kind of the same. The 4th one's a little bit the same but different. All right. So here's what we're gonna do. First of all, I'm gonna draw an altitude. Oh, you know what I need to do? I'll tell you. I'm gonna make this a little smaller because I want to make 2 triangles, not just one. So I'm gonna copy. We can make an orange if you want. I'm gonna make it smaller though. Okay. And what's an ugly? Which one?
That one's good.
That one? Squash
Oh no.
or sunshine? Sunshine. There we go.
Yeah. If you have to use another color, use green.
Okay.
Not pink green.
All right. We're being too silly. Let's continue.
We're girls.
I know you are. Let's go blue. Oops. All right, here we go. What we're going to do here is I'm going to draw an altitude. Let's take this angle up here. Let's not make it 3 points. Make it 2. And I'm going to draw an altitude. What's an altitude if I take it from this vertex right here? Where do I go? Let's not say straight down. Yeah, perpendicular. That's what I want to hear. I want to hear perpendicular to the opposite side. How many times have we said that? Like 1,000,001, I think, today makes it. All right, so that's perpendicular. Now watch what I'm going to do. I'm going to go to the other corresponding angle. Okay, so I just copied and pasted. I didn't twist or flip or anything like that. So what's the other corresponding angle over here? This top one. Would you agree? And I'm going to go perpendicular to that opposite side as well. And let's put some letters in here. Let's call this, we'll call this ABC. I've already got it written down. And then this is D right here. And this is F, G, H, and J. This is straight from the book, okay? I mean, the triangles look a little different maybe, but the letters are going to be the same. Now, here's what we've done. I've taken 2 triangles that were similar triangles to begin with. So I need to write that down. Did you see how I copied and pasted? And then I hit the shift key and I made it a little bit smaller. So they're similar triangles. So triangle ABC is similar to, actually, sorry. I just want to stay consistent with what I have on my paper. ACB is similar to triangle FHG. FHG. Now this, it does? ACB, FHG. No, that's just right. All right, so I've got these 2 triangles similar to each other, and here's what we know about this. We're going to do some more proportions. This whole chapter is about similar triangles and about sides and angles. No, not angles really, but sides being in proportion. So what we're going to do is we are going to take a look at the 2 blue ones. The 2 blue ones are the what? What word did I use? I went from a vertex perpendicular to the opposite side to an altitude. Okay, so this is all about altitudes.
Parts of similar triangles.
Parts of similar triangles. No, it's not all about altitudes. Jerry Falwell, you ever hear of Jerry Falwell? I wish I would remember the quote exactly. I hardly remember anybody's quotes exactly, but he said something about it's your attitude will. Oh, see, I should have never started it because I always mess up when I try to say other quotes. It's your aptitude. No, it's your out. Let's start it again. It's your attitude, not your aptitude, that will determine your altitude.
Oh my God.
Did you get that? See, I told it. Did you understand it? It's your attitude. You know what an attitude is, right? Having a good, positive attitude. Not your aptitude. What does it mean, your aptitude? Meaning like how smart you are, how much you know. It's your attitude, not your aptitude, that will determine your what? Your altitude. Your altitude is how high you'll go. Your, your goals for the future. You know what what you're going to become. So it's your attitude, not necessarily your aptitude, that will, what did I say? Determine your altitude. There you go. So there's your spiritual nugget for the day. All right, nugget. Yep. I did not. That's the first time I've ever said it in all my years of teaching. Right there. I just thought of it when I saw altitude. You should feel special. Okay, so what do we do here? What we have here is we have, I'm going to do a comparison. I'm going to make a ratio of the altitudes. And what this theorem says, it says if two triangles are similar, the lengths of the corresponding altitudes are proportional to the lengths of the corresponding sides. Do you hear me? So if I compare the altitudes, it's going to be the same ratio, or they're going to be proportional if I compare the corresponding sides to each other. So let's first of all compare the altitudes. So what are my altitudes? AD. Compare it to what? FJ. Everybody see that? So I compared the altitudes together. Now, I can set up a proportion. What other things could I set proportional? What can I do? The other sides. So the altitude is proportional to the other sides of the other corresponding sides of the triangle. So I could go AC, couldn't I? So what would I compare AC to? AC to what? FH. Good. And I could do a few more, couldn't I? What are my other sides of my triangle? AB. And if I go AB, I go to FG, right? And what's my third one? CB to what? HG. Everybody see that? So this right here was my altitude. So if I compare the altitudes to each other, and look which direction I compared them. I compared the left one to the right one, or the bigger one to the smaller one, right? Everybody see that? So how do I compare the corresponding sides? The left one to the right one, or the bigger one to the smaller one. Does that make sense? Okay. It's pretty easy, isn't it? All right, it's a nice little comparison. And you know what they're going to do, obviously. They're going to give you probably like 3 of the sides, and one of them will make X or something. You just have to solve for X. But it's a matter of setting them proportional, okay? Does that make sense? So we took the altitudes, and we set up a ratio with the altitudes, and it's going to equal the same ratios of the corresponding sides. So the altitudes are proportional to the corresponding sides. You got it? So that's a nice short way to say it. What did I just say? The altitudes are what? Are proportional to the corresponding sides, okay? Or to the ratio of the corresponding sides, if you want to call it that. Make sense? Yes? Okay. Let's just copy these. Let's do another one. Let's scooch this up. Let's do this. Well, might as well just use the same exact triangles. Mine look a little different in my notes, but this is okay. What I'm going to do now is I'm going to bisect this angle up here. See what I'm doing? I'm bisecting the angle. Does that necessarily mean it hits the midpoint of the opposite side? No, not necessarily. Okay, but I am bisecting this angle, so I'm splitting this angle into 2 equal parts. So if I bisect this angle over here, what do you think I'm going to do to this triangle? Bisect the angle to that. Now, these 3, I'm going to do 3. The first one was about the altitudes. This one is about what? See, this is altitudes. This one here. What do you think this is? What am I going to write down? What did I just do? This and this are equal, and this are equal, right? I'm going to do angle bisectors. That's right. So let's write that down. Say what? I was supposed to? Maybe later. Lime green. Which one? Is that little sprout green, or jade, or mint julep? Which one? Little sprout. Okay. So, by the way, let's put some letters in here. This is Q, R, S, and T. And this is K, L, M, and P. Alright, so we've labeled it, and we also have to tell you that these triangles are, guess what? Anybody gonna guess? Which one? How about similar? Triangles are similar to each other, so KLM. Now this has to be true. The triangles have to be similar for this to work. This is not true just about any 2 random triangles, okay? It only works if the triangles are similar to each other. So now I took the angle bisectors, okay, of these 2 triangles, and guess what's true about that? We could probably set up a ratio with this. Okay, it's not an altitude, but it's an angle bisector, but the same thing holds true. What do you think we're going to do here? Any ideas? No? What do you think we're going to do here? We've got angle bisectors instead of altitudes. What did we do with the altitudes? We set up a ratio, didn't we? Do you see that? And it's proportional to the corresponding sides. So what do you think might be true about this angle bisector? Same thing, right? They're proportional to the other sides as well. So let's set up our angle bisector proportion first. What would that be? RT to what? To LP. Right? I'm just comparing the two angle bisectors. Right? Not the angles themselves, the actual bisector, the line segment or the line or the ray that bisects those two angles. So I'm comparing RT to LP. Now I said line or ray. That would not be true. Okay, you can only, because they don't have one length. They have to be line segments. Sorry about that. I want to make sure I say the right thing. So line segment RT, if I compare it to line segment LP, what do you think that's going to equal? Well, it's going to be proportional to the corresponding sides of the triangles. So give me some other sides. RQ. All right, I heard RQ first. So RQ to what? LK. Give me another one. RS. Okay. RS to what? LM. Good. And what's my third one? QS to KM. Everybody with me on that? So I can set up those ratios. Now, again, you know what they're going to do. They're going to give you some numbers. They're going to give you some variables. And you're just going to have to solve. But once you set up a ratio, then it's pretty easy to solve, right? Little cross multiply. No big deal once you get the numbers in there. So this was the angle bisector. I compared the angle bisector from one to the other, and then I can compare the corresponding sides of the triangles, and they will all equal each other if I reduce them all down. We good? All right. Then there's a third one. Let me copy and paste our triangles again. Actually, I think I already did it once. I don't have to do it again, but now we're going to do something else. So what did we do first? We did an altitude first, right? We went perpendicular. And then we went from this angle up here and we bisected the angle. What else can we do that we've done like in the last chapter? A median. Very good. Go do the median. So that starts at an angle and it goes where to the opposite side? Yeah, let's say midpoint. I like midpoint better than saying middle. Okay, we go to the midpoint of the opposite side. Does that look midpointish right there? Pretty close. All right, and then let's go to the midpoint of this side. That looks pretty much a midpoint. Good enough for us. And let's put some letters in here again. Let's go A, B, C, D right here. And let's go W, X, Y. And put, I'm sorry. Yeah, that's right. And then put Z right here. All right. So what do you think? Well, I need to do this first before I... Oh, why did I do that? Let's make it thicker. I need to go... There we go. Thickerer. Yeah, we'll say not equal. Similar. Right. So ABC and what? WXY? Yeah. Alright, well, we had to know that, alright? And what are these two lines? This AD. Remember, it hits right here. Hits right here. What's the name of AD and WZ? What are they? They are what? Medians. Remember that? Medians. Because they go to the middle or the midpoint. It's better to say. To the midpoint of the opposite side. Remember that whole story about the median, don't you? The other chapter about the road thing in the middle of the road and all that stuff. Okay. All right. So let's set up a little proportion here. What do you think? Let's set up a ratio with the medians. Now, I've been going the left one to the right one. If you wanted to, you could go from the right one to the left one. Couldn't you? It doesn't make any difference. But, I don't know. I just stick with the same order that we've been going. So I could compare AD to what else? WZ. So that right there is my median. But now that's proportional, right, to the other sides, the other corresponding sides. So we've done this before. Let's do it real quick. AC to what? WY. What else? AB to WX. And then our last one, CB to YX. And that one right there is our median, isn't it? These are just the corresponding sides. These are the ratios of the corresponding sides. And so they're all equal to each other. It means they're all in proportion. They're proportional. And there we go. What do you think of that? It's pretty easy, right? Aren't they all pretty much the same kind of deal? Yeah, as far as setting up the ratios, they are. But they're all three different things, though. That's an altitude. Okay, they're in proportion with the other corresponding sides. The angle bisector, that's in proportion, right, to the other three sides of the triangle, the corresponding sides. And the median was the last one. And that's also proportional to the corresponding sides. Pretty simple, right? Let's do one more. This is only one triangle, so let's get rid of sunshine here, and we'll use whatever color this is. I don't even know what color they call this. I don't know. What do they call it? They call it pure magenta. How's that? So fancy. That'll be too close to this. What other color? I've been using blue. Have I gone yellow today?
No, the other one. No, the other one.
What yellow? This one?
Yep, yep.
It's the same yellow.
No, it isn't.
That's pure yellow. That's global pure yellow.
The other one
I don't know the
prettier.
difference. This one?
Yes.
They're exactly the same.
No, they're not.
Yes, they are. All right, watch what we're going to do here. Watch what we're going to do here. Let's start it with, I'm tired of bisecting this angle all the time. Let's go down here just for fun. All right, let's bisect this angle. So what I'm going to do is take this angle right here. I'm going to bisect it. But now I'm not comparing two completely different triangles, am I? All right, I'm looking at this one triangle and just bisecting an angle from one triangle. But it does form two triangles there, doesn't it? Yep. So that's J and K, M, and L. All right. So what have I done? I've bisected that angle J right there. And let's see. We got a theorem. This has got a name. This theorem has a name. It's called the triangle angle bisector theorem. All right. So you got a triangle. You bisected an angle from a triangle, and this is the theorem that's true about this stuff right here. Look what it does. It's called the triangle angle bisector theorem.
Can we just do like the triangle symbol and then the angle symbol and then
Absolutely.
BIS?
Yeah. Let's see how I want to explain this. I can just read it off. It says an angle bisector separates the opposite side. Now watch. What's the angle bisector here? Name for me the angle bisector.
JM.
Right, JM. Line segment JM. That's the angle bisector. And it says it separates the opposite side. What's the opposite side of the angle that it's bisecting? KL. So it separates it into two segments. What are my two segments? KM and LM. Right, those are my two segments. So it separates those two segments that are proportional to the lengths of the other two sides of the triangle. Hear what I just said? This angle bisector right here hits there. Doesn't hit at the midpoint, does it? Not necessarily, okay, but it hits the opposite side. It breaks the opposite side into two segments, KM and LM. Those two segments right there are proportional to the other two sides of my original triangle. Did you hear what I said? Tell you what, it might be easier just to do this. Let's call this A, call this B, call this C, call this D. Is that all right? So watch what we can do. What did I just say? I said that this bisector splits this third side, or this opposite side, into two segments that are proportional to the other two sides of the triangle. So I could do a couple things. I could do what? I could compare A to B, right? I could compare A to B, but what would I do? It's proportional to the other two sides. Now look, which one of these, C or D, connects to A? The C does. So where do you think that's going to go? It's going to go right here. And which one corresponds or connects to the B? The D. You see that? All right. So I could go A to B equals what? C to D. Everybody see that? Let's see. Now remember, it's a good question because let's try it and then we'll cross multiply and see if they come out to the same thing. Remember did that the other day? If you cross multiply and they come out to the same products, then yeah, then they're the same. All right. So the question was, can you go A to C and B to D? Well, let's try it. A to C equals B to D. is this the same as this? Well, let's cross multiply and see. What do we get? AD equals BC. What do you get here? AD equals BC. Are they the same? Yeah, so can you compare them that way? Absolutely. You okay with that? Which way could you not compare? A to D and B to C, right? You can't do it that way because look, the A and the D have nothing in common, do they? Nope. This segment A has got nothing in common with D right here, and B has nothing in common with C, so you can't relate them to each other. But look, A and C do have something in common, don't they? They meet at that common point. B and D have something in common. They meet at that point. You got it? If I compare A to B, they have this in common. C to D, they have this in common. Get it? All right. Now look, there's a lot of stuff to remember about all these ratios. What compares to what? But you got to review it. Make sure you go over it once in a while. And there you go. You want to do a quick example here?
No.
A real hard one? Let's do one like this. I'll draw it myself. Let's do one. What color haven't we used? We never used these
Purple.
blues.
No, use that one. No.
This one?
No, the one over to the purple. No.
This one?
The next one.
This one. Amethyst?
No, the next.
Raspberry?
The
That?
yes.
Purple.
Purple. That's what I said. I said use purple.
It didn't look purple to me. It looked blue. Now it looks purple.
It looked purple.
When it was next to the blue. Let's do this. Let's make it look. This is an example from the book, okay? So it's nothing.
Make it
I'm not
thicker.
just making up. Alright. I'll make it thicker. So let's do this. Let's
Do
make
it
it
4.
4?
5.
Oh my goodness. No way. Crazy.
So
You can't do it. 5?
5. Just try 5.
Nuts? No way.
No.
I'm not that crazy. Alright, let's put some stuff in here. What goes? Yellow goes good with purple. Oh, you know what I got to do? I got to do an angle bisector, don't I?
Yeah.
So let's bisect this angle right here. Does that look like it bisected it?
Yep.
Pretty close. Alright. Yeah. So we've bisected that angle, and let's put some stuff in here. Let's say that that's X. Let's say that this whole segment right there, whoops, probably went a little too far. About right there,
Why'd you stop?
because I'm going to put a number in here. 18. Alright, and let's say that's 14, and let's say this is 6. Everybody with me? Okay, now, what do we have to do you think? What do we have to solve for? It's for x, obviously, okay? So we got to solve for x. So we got to set up some proportions. Remember that? Remember, this is the angle bisector, and it splits this opposite side into 2 segments. Problem is, I don't know what that is. Is that 18 right there? No. What do you think I'm going to make that?
18 minus x.
Very good. This is 18 minus x. All right, because if you knew this number, you could find this just by subtracting, right? So that right there is 18 minus x. That was the hardest part of doing this whole problem, I think. All right, just realizing that. So now I can make a couple comparisons. How could I compare these? X to what?
6.
To 6. Okay, we'll go x to 6. Now, if you go x to 6, what are you going to do here? 18 minus x. So it's not 18x, it's 18 minus x over what? 14. Now you could have done it another way. You could have gone what? X to 18 minus x to what? 6 to 14. You see that? Or you could go the opposite way, right? I could have gone 14 over 6 equals 18 minus x over x. Doesn't matter. They still cross multiply to be the same exact thing. So let's go ahead and cross multiply. What do we get here? That's 14x equals. Now you got to be careful with this. What do we have to do with this?
Distribute.
Distribute. All right,
So
put that in
it's-
parentheses. Did you notice that?
Yep.
That's really important. Somebody have a calculator on them? What's 18 times 6? 72?
108.
108?
Minus 6x.
108 minus 6x. Okay?
20x.
Add a 6x to both sides, right? Which gives you 20x equals 108. And divide that by 20, that's 54, right? And then a 10 is 5.4. Did you get that? So it's 5.4. There you go. But what was the key to this? The key was setting this up, wasn't it? That was the key. The rest is just algebra. That's no big deal. It's that part right there is the geometry. That's the part that I want you to understand for today.
Okay.
We good?
Yep.
All right. Homework.
Where do we not have homework?
You make me laugh. You're so funny. Did you ever watch that movie? Watch that movie last night where Tom Hanks is in it, and he falls for his teacher. He gets fired from his job at Walmart or whatever. You ever see that one? And then the teacher, he's George Takei. Do you know George Takei? He was from Star Wars, and he's teaching his class, and he does this thing. I never remember names of movies. But then, shh, wait a minute, let me tell my story. And so, I know. Let me tell my story, and I'll be done. So he gets up there, and he's like, he says something, and he goes, ha, 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 ha. He says, oh, that's supposed to scare you. Did you ever see that? You got to watch it. It's pretty funny.
I've seen
because he's really, really creepy. He's really, really creepy. Oh, that was old. My goodness, that was like one of his first movies. All right, here we go. It's page 4. It's pages 499 and 500. 500. Numbers 6 to 23. And you can omit. I'll let you omit.
What's that mean?
Oh, stop. We've talked about that over and over. 18 and 19. Right. Yeah, even if you didn't know what the word meant, just looking at the context, you could figure it out. All right, that mid-chapter quiz. Sorry we couldn't go over that today, but this took the whole class period. But I do want that. So pass it to the front. That mid-chapter quiz we went over. Pass it to the front. And this will be your homework for tonight. Looks like we got a quiz on Friday, 7-3 and 7-4 on Friday. Everybody hear that? All right, that's it.